Okay, so before lunch we were saying that we could add and subtract them as long as they had the same number under the square root. And that sometimes we would need to simplify because, right, we should never be working with the square root of 8 even to start with. The square root of 8 is like, would be like working with 5/10, right? We write it as 1/2. The square root of 8 we turn into 2 square root 2. Okay, multiplication. What was our rule with exponents if we wanted to multiply 4x squared times 2x to the third? What did we do?
We added,
Right, so we dealt with the 4 and 2, and we turned that into an 8. And did it matter that the x's exponents matched?
No.
No, right? It didn't matter that those were the same. Our rule happened to be to add the exponent. Okay, so our multiplication rule with radicals says it does not matter if the number underneath the square root matches. Okay, so they can have different numbers in the square root and we can still multiply them. So if we have something like 3 square root 5 times 2 square root 2, it's okay that the square roots do not match. Okay, we will multiply the 3 times the 2, which gives us a 6. And then we will deal with, just like we did up here, the x's. So we will multiply 5 times 2, which gives us 10. And so 3 square root 5 times 2 square root 2 gives us 6 square root 10.
I feel like this is the easiest one.
Okay, the outside numbers get multiplied together, the inside numbers get multiplied together. Okay, so 3 square root 6 times 5 square root 8. What are we going to do?
15 square root 48.
Okay, so we'll multiply the numbers on the outside. So 3 times 5 gives us 15. Then we'll multiply the numbers on the inside.
48.
If you put that in italics, you would be wrong. Why would this be wrong? Right? Because it's not simplified. It comes back to that basic idea that we just simplify. Why? Because we always reduce a fraction. We always simplify a square root. So we would prime factor this 48 by the rules that we talked about last week. So hopefully, like, we can prime factor. Okay, that's something we've been doing since we started factoring. That's something that was a standard in middle school. It's something we should be able to do. Right, so we have 1, 2, 3, 4 2's. Bless you. And a 3. So what do we have pairs of?
2 and 2.
Could be 4.
Each pair counts 1 time.
2, 2.
Okay, so a 2 comes out in front, a 2 comes out in front, a 3 stays inside.
We just put 4 in.
What about 2?
Okay, but right, our answer isn't 4 square root 3 because one number was already out there. The 15.
Why'd you put 4 and 2?
What's 15 times 4? 30.
Well, 15 times 2 is
60.
30. 30 times 2 is 60.
And then you have to do it again?
Nope.
Oh, okay. I wasn't going to do it anyway. Ping pong.
Okay, so overall, our large objective is that if we can add them, we're going to add them. If we can multiply them, we're going to multiply them. And then we're always going to get our answer in simplest form. Okay.